All right. Smart man turning that microphone off. Hello, and welcome to MLS. We're 1 minute after time, so let's get started. I'm Sean Turner.
Nick Sullivan.
This is the MLS Working Group. We're at IETF116. Let's go on. It's not the working group ID status. I'll have to change that at some point. This is the note well. Again, it's Thursday, so hopefully you've seen these a little bit. This is the, if you know about patent, see something, say something. There's some anti-harassment procedures and policies and code of conduct, et cetera. Luckily, we've had none of the problems that we sometimes have in the IETF. This group has been very collegial and very polite. It's been nice. All right, some meeting tips. We got a meeting tool. Please scan this QR code so we make sure we have a room that is the right size for people the next time. Otherwise, we will get a closet. And if you want to get in it's also how we're going to manage the queue to work with the remote participants. So if you want to get in, you make sure you get in the queue, and I will manage the queue from up here. All right, some more resources. If it gets there, it's a little laggy. This is from the template. I meant to delete this. All right, our agenda is pretty straightforward. This is the administrivia, the blue sheets. Again, scan the QR code. We do need some scribes or a scribe to use the tool to take minutes. Anybody? We don't need a blow-by-blow description. All we need really is action points. I see there's some arm twisting going on. I really appreciate that. I'll buy you a Coke at the break. All right, I think we found a scribe. I appreciate that. There's a note-taking tool if you log in. Appreciate that. Are there any revisions that anyone would like to make to the charter? We're basically going to try to talk about each one of the each one of the drafts that we have. We got some slides. It's maybe not organized the best, but it's going to provide a little status update on the implementations in each one of the drafts, and then some other individual drafts that Rowan keeps pumping out for us. All right, not hearing anything. We'll do our typical, in case you don't know how this works, this is where we are. So this is our status document. So we've been kind of going around this chain. With protocol, we are approved. It is in the RFC editor's queue. Yay. We have a successful protocol because we've made t-shirts and stickers. If you do not yet have a sticker, you can see me at the end because I got a whole bunch of them. Yay, so that's fun. So that's great. So we're basically going to wait. It usually takes about 2 months for the RFC editor to get through the queue because you start at the bottom and you work your way up. So in about 2 months, we'll probably end up with a number. So that's great. And there'll probably be some kind of minor editorial corrections, or, they copy edit the draft to make sure the comma's in the right place and stuff. So we'll have some minor changes. And then for the architecture draft, it's not quite as good. So the little thing at the bottom is what the ballot looks like. And so we need 10 of those little boxes under the, I don't know if you can see my cursor over here. We need 10 of those, and they all got to be green and no red. We got some reds, so we got to fix those. There's one abstain, and that's fine. But we're basically, we have a group of people, primarily, I think, led by Hecker, who's going to try to provide updates to get the document done and out the door.
There are PRs for 3 of those registrants.
Great. So we just have to get them reviewed and the whole 9 yards. Great, Ecker. If you want to get up and say something, that'd be awesome. Thanks.
Yeah, I mean, so TLDR, yeah.
Thank you. The TLDR is, the purpose of this document was in part to be a clear exposition of how MLS worked. And over the years, as more attention was paid to protocol and less to architecture, tended a bit rotted and did not provide as clear an exposition as we were hoping. We went and took the pieces that we thought were absolutely most critical to make the protocol document explanatory, probably getting explicatory into protocol. And I think now we're going to spend some time on the writing of architecture. You can see some of the sort of complaint, some of the sort of not as awesome as it is reflect and discuss, but we're hoping to make a complete pass through it and make sure it's actually clear in places.
Yeah, fair enough. I mean, there was 20 revisions of the protocol document, like half as many for the architecture. So it's just clear. And this is just part of the normal growing pains of getting a document through the process. And I think the differences in protocol, people could really dig into it because you could, you're describing the protocol fields where the architecture draft is a little bit more free flowing and describing of ideas. So we'll get on that and get it done. They're, at one point they were coupled, so one couldn't get published without the other, but we've kind of done some decoupling so the protocol document can be published without the architecture document. And that's all great. So let's jump back in here. All right, Richard, you're up. Typical pink slides. All right.
Oh, cool. Right. Awesome.
Purplish.
Yeah. So this is.
Did you pick this color to match the shirts?
I did not. I did now. I need to rotate it a little bit so it's a little more purple instead of pink. This came out of an ugly slides battle between Martin Thompson and I liked it so much I kept it.
So do you want to drive or do you want me to drive?
If you got it up already, you go ahead and drive.
Yep.
Scrolls forward in the slide. Sean already talked about the fact that we've gone through a few revisions. The major one was this draft 18 that resolves the discussed positions we got when our ISG evaluation. Wasn't anything major in those. The more major change we made was this grease thing. Our distinguished colleague, David Skenazi of the Internet Architecture Board, came around and suggested we do this grease approach to maintaining extensibility and avoiding ossification, which has worked well in some other protocols, the IETF, which involves, inserting random values in some fields where the receiver of that field is supposed to ignore unknown values. So we wrote that in and then published the new drafts, and Brendan promptly found a bunch of errors that we needed to fix and how we had implemented that. And so we cut draft 19 right after to fix those nits. Both in draft 18 and draft 20, we fixed a few minor consistency things and ambiguities that we found while we were doing some interop testing. But basically, it's been a bunch of minor changes in those last few drafts that Sean pointed out. So speaking of interop testing,
Richard, before you go, are you going to talk about interop testing?
that was what I was going to do on the next slide.
Great.
Yeah, so since the spec,
I got these minutes ago, so none of us have reviewed these.
So since the spec's getting about done, we started taking a few up of the implementations that were out there and verifying they all interoperated. And the cool top line headline here is that we now have full interop on pretty much the whole spec between the MLS-PP stack that we use in WebEx and the Wicker stack that they're developing for their application. So we've got lower levels of interop verified with a few other stacks, but we have pretty full spec interop among those two. So that gives us pretty good confidence that this thing is ready to roll. So I was really pleased with that result. Just to give folks an idea of what we're doing here, we've got 6 different implementations. We've got, I think, roughly half of them open source, half of them not open source, a variety of languages between C++, Rust, and Java 1 just came along. We're kind of doing 2 different styles of interop testing. We've got a bunch of test vectors as kind of the first level of testing that cover the deterministic parts of the protocol. The idea is that you can take these test vectors that were generated off of one of the stacks, different stacks implemented, generated different test vectors, but they're all implemented by one of the stacks. But you can take these test vectors and you can run it against your stack, put it in your, use it as unit tests and things like that. So it's kind of one party, you test it on your own. We also have a gRPC-based framework for doing live tests. And what we've done is we've devised a collection of test scripts that cover all the functionality in the protocol, and we do some deeper probing to make sure that corner cases get covered as well. And the way these work is you spin up 2 or more stacks or 1 or more stacks that you want to verify interop. And then those things act as gRPC servers, so you can send RPCs to them to do protocol operations. And then there's a test runner script that runs these scenarios across the two or more implementations that are under test. So basically, we've got a bunch of progress in the test vectors across several implementations. I think there's at least 4 of these 6 implementations that have a bunch of the test vectors covered. And then MLSPP and Wicker and OpenMLS have done a bunch of the live testing against one another. So I think the hope is to get more folks implementing, more testing going on among folks. But I think overall the testing has been pretty clean. We found a bunch of implementation bugs. We found, like I said, a few minor things in the spec, but nothing major. Most folks are pretty much on the same page. If you'd like to participate, there's links at the bottom for the repository where we're tracking all this stuff, and the Slack channel where we're having ongoing discussions. So I think that's all I had to say. I just wanted to show my celebratory meme slide to celebrate our approval and say we are off to the RFC editor now to go get our number, as Sean said, in a few weeks here.
I'll use the tool to join the queue. Just to, please keep track of these interop tests. Richard, you might not care about internet standardization levels, but some people do. And if this does get deployed widely, as you think it will, we can use all of those to just ask the ISG to update the level of standardization.
Sure.
So you can go from like proposed to full.
Yeah, we've got a like a Google spreadsheet that we're tracking at least test vector results in. I can drop that in the chat here or on the mailing list.
And that's all we need.
Okay, cool.
Yeah, I can write the wrapper that goes around it.
Yeah, it's a little, so test vectors are easy to explain. The live testing is a little bit harder because that's, it's a protocol that does groups. And so we have this combinatorial thing of like, which stacks do you have involved? Fortunately, our tooling generates all the combinations we need. But it's a little harder to say, we tested these N combinations of clients together, but I'm sure we can find something to write out.
Okay, thanks.
Sure.
So the next document we were going to talk about is architecture, but I think we're going to put a pin in that because I don't think rolling through each one of the PRs to describe whether it's going to make any sense right now. So the next one is actually the next set of slides is Raphael's, where he's going to go over both extensions and federation. Thank you, Raphael.
Wow, that's much more appropriate. Okay. Yeah, so I mean, I think the really important part is what Richard said. We were really focused on the protocol in the past weeks and months. It's great we're there. So the effort regarding everything else has been much lower. Yeah, next slide. So yeah, we have this federation document. The status is still the same. It's stable. There's a new version uploaded to keep it alive. So we are waiting to see what happens in the MIMI working group, and I think some of you might have attended this morning, and you probably noticed that it's very much alive. A lot of discussion happening. So yeah, again, the idea is to wait to see what happens there and then see how we position this document. So just for context, this predates MIMI, and the idea was to open the field a bit regarding federation. That's now the core mission of MIMI. So we'll see what we do with that. Yeah, next slide. Richard.
Just briefly on the Federation doc, just to put the idea out there, there may be some non-MIMI cases where having a standard DS API would be useful. Folks doing kind of interrupt between real-time conferencing systems, for example. But happy to discuss those later on. And I don't think there's any special urgency to it.
Yeah, that's a good point. So yeah, in general, I should say I'm happy for any sort of feedback in that sense. And also, as you said, if it's stuff that is not going to be in MIMI, then it should exactly be in Federation, but we don't know whether it's going to be in MIMI or not at this point. So we should wait for that. But happy to start any discussion regardless. Yeah, next slide, please. So yeah, then as of fairly recently, we have this extensions document, which started out as a place, a bit of a dumping ground for stuff that didn't make it into the protocol. And so we looked into making this a little bit more formal and try to see what structure we should adopt here. So on a very practical level, there has been a very late addition to the protocol document regarding IANA registries. So we have flexible wire formats now. We have labels for domain separation, for signatures, public key encryption, and exporter. And that is, of course, something that extensions can use. So that's very relevant here. And in fact, the targeted messages extension now has its own wire format, which is, I think it was initiated by that extension, but others will certainly follow, I could imagine. Then we have added the content advertisement extension, and Rowan is going to talk about that in a bit. Also, so that was proposed as an independent draft initially, and that made it into the extensions document. So this is a dynamic that works, obviously. If anyone is unsure, can always publish a draft, and then we can have some discussion. Alternatively, you can also file a PR against the extensions, and we can discuss it there. Both ways work. Another draft in the same vein that has been proposed by Rowan is a group anchors draft. He's also going to talk about that in a bit. And then finally, more about extensions in general. There has been some discussion between Joel, Marta, Conrad, and I to think a bit about giving some guidance on how extensions should be structured, what the security implications are. So none of that is in the document yet. So this has mostly been discussions. And yeah, I asked Roy to talk about that. And I think that is already on the next slide. You can check. Yeah, Roy, floor is yours. Thanks.
Oh, hey.
Great. Oh yeah. Okay, so safe extensions. The idea here is we want to build an extension which provides an API. We're calling it the Safe Extension API for lack of imagination. And the idea is to bring a bit of sanity into how we build extensions. Because right now these extensions, like, this is a bit of a free-for-all. We can define all kinds of extensions, and so there's no, they can break things, they can interact in weird ways, and that makes it hard to analyze and to build these extensions, because you really have to analyze them. You have to think about how they're going to be used in, like, anything else you're going to use. You're going to have to think how that interacts. And so to make that whole job simpler, to make it easier to build extensions, that's what this idea of the safe API is, right? So yeah, the purpose is kind of twofold. First terminology, we call a safe extension is an extension that only interacts with the MLS session via this API, right? So there's the safe extension API, which is an extension that gives us the API. And then you can build extensions that interact with the session via this API. I'm going to call these safe extensions. And now the guarantee that the API gives us is twofold. The first is no safe extension is going to harm the core security properties that vanilla MLS has been analyzed to give us, right? So a safe extension is not going to break anything in MLS is the clean way of saying that. And it goes further, they're also not going to break each other. you can, and from the designer's perspective, that means you can design your safe extension and analyze it in isolation. Like analyze it in a setting where it's just MLS running with this safe extension. And whatever properties, especially security properties, you conclude that it has, you're guaranteed that it's going to keep those security properties regardless of what other safe extensions it then gets composed with in an actual session. So that these security properties are composable with each other. So it makes it much easier for us to design these things and analyze them. So we can work in isolation, and it extends to however we actually end up using them. So that's the goal of this API. Next slide, please. Sorry, Rohan?
When you say session, do you mean group?
Yes.
Okay,
Yes.
thanks. And Rowan may.
So just some ideas of like, you know, what could you do? What kind of extensions can we hope to build from this API? Not everything we ever want is going to be able to, we can make it as a safe API, but still it looks like already there's some pretty useful types of extensions that we can implement as safe extensions. So a good example would be role-based access control for MLS, right? That means basically the concept of a moderator in a room, for example. You know, we can build an extension that implements role-based access control in a relatively generic way, actually. So that's something we could do with as a safe extension. A little bit more technical. Also, you can have a safe extension that allows applications to import data into the group. And so we inherit all the nice properties that this MLS session gives us, right? Like, so cryptographic agreement on this data that's imported from the higher level application. So this import feature, this is also something we can do via safe extension, exposing some of the keys that are inside this cryptographic state, right? We have these ratchet trees. We've got all these signature keys. Everybody's got their own signature key already and HPKE keys at their leaves. Sometimes this kind of stuff is also useful for higher level applications. So we have a safe extension that safely exposes these keys. So it doesn't give the keys because that wouldn't be safe, but it gives an interface to the keys so that higher level applications can use them. And again, the guarantee is it's not going to harm the session. So it essentially enforces key separation. In fact, one of the things you can do with this is exactly this one-on-one messaging, right? So you can use the ratchet state that you have and these keys in this ratchet state to also do one-on-one messaging. That's something you could build on top of this extension to safely expose keys. Another one is a sort of a smart idea for post-quantum, how to do post-quantum, which gives you a little more flexibility than just saying, oh, we're going to use a post-quantum chem or something, because they're kind of, the point is you have to pay the price for every single operation that you want to do at the ratchet tree level. You always, if you're going to use a post-quantum cipher suite, you always, every step, you're always paying the price of the post-quantum primitives. And you can separate that out. And so you can say, well, I want to like, maybe only every 10th commit is actually going to be a post-quantum commit. And so the other ones are more efficient, classical, and like every 10th one, you're really going to pay the price of post-quantum. So this sort of separating out post-quantum. That's another thing you could do as a safe extension. What else we got? Oh yeah, application triggered custom event injection. And then alternative application message formats. Again, one-on-one messaging is an example. We also came across a use case that where signatures on application messages really wasn't necessary, and you know, you'd have to modify MLS to actually strip off those signatures, and so instead you can do that with a safe extension. You don't have to worry about affecting anything inside MLS. So these are just examples that demonstrate the viability of this API, that it's actually capable enough to do some stuff. Yep, Michael.
Hi, Michael B, UK NCSC. It's possibly a dumb question. You say that safe extensions can't interfere with each other. So is it going to be there's a list of safe extensions that anyone can pick from, but something's not going to be added to the list if it interferes with any of the others that are on there?
No, actually, it's more like every extension you register with IANA. That's sort of the one precondition. The extension has to register with IANA, it gets its own number. And so that gives us domain separation. And then the safe extension API relies on that. But it's not like there's going to be some list. In fact, that's the kind of the point is, as a designer, you don't have to care what else exists. you might end up getting your extension composed with extensions that haven't even been invented yet, and it's still okay.
Okay.
The
thank you.
API takes care of the separation for you.
Okay. Thanks.
All right. That's
right.
that.
Great. Thank you. I'm looking forward to this because I'm trying to figure out how this is going to work because it's safe extensions is an extension that tells you the list of extensions that are safe, or is this rules that go to the designated expert when they're being defined and they get like a tick in the INR registry? That's the only thing I'm trying to figure out. Is that how it works basically?
I mean, a tick in the INR registry sounds like a good idea.
Yeah. So this is it. When they get registered, we can define the rules. Like if you're going to get this, you have to, if you're going to say it's a safe extension, right? The designated expert pool has to agree, and then they can get that tick, and then they can essentially, I hate to say it's almost like a criticality flag that was in X509, right? It's like this extension is safe.
Mm-hmm.
Is that what this is? So you're saying this field is going to be included in every extension.
Yeah, I mean, I guess so.
Okay. Yeah. Okay. All right.
I mean, it's relatively easy to verify because all you got to do is just say, is it only using this API?
Ah. Okay. Okay.
So
Okay. Cool. All right. Great.
You guys publish this?
no, this is work. This is work in progress still.
Yeah. I mean, I can't wait to see it.
If I can just add one more thing, Rafael Robert again. So we didn't bring this to the list yet because it's so much work in progress and not fully organized yet, but obviously we wanted to present it today, and it's very much open for comment, and we will bring that on list hopefully soon.
One quick question. Is the expectation that extensions need a draft or an RFC to be registered with IANA for the safe extensions?
Isn't that a rule for IANA in general?
Yeah, so it ends up being specification required, so we can write the rules for what a specification is, but yeah, any internet draft could work, but you have to publish something, right? Because otherwise, then we won't know how it works.
Right. With TLS, you have an extra check mark for recommended, which is if it actually has an RFC.
Right.
Right. Yeah, I mean, I don't see how else it would work. I mean, if you just talk about it, then it's probably not substantial enough and not persistent enough. So
the idea is that going through the process of getting IETF consensus raises the bar significantly, right? But that maybe is what's required to make sure that people think it's actually safe.
I mean, there are still the two options. Either it is in the extensions document, and then we don't need to adopt that document because we're already adopted it. If it's a separate draft, then there's this additional step of getting it adopted. But yeah, in terms of safe extensions, the bar should be the same for the two, so that should be independent. But in either case, it is either a draft or a PR towards the extensions document.
Yeah, the other thing to keep in mind is that MLS will still have to be a working group if we would need to have new RFCs.
Right. Yeah.
Or
that's what we assume. Yeah.
Yeah.
All right.
Okay. Hi, I'm Rowan May.
So
I have a-
we have 15 slides and we got 30 minutes, so I'll let you manage.
No problem. Okay, next slide, please. So we already have this section 2.3 of the extensions draft is content advertisement. There's nothing that hasn't been already available for people to look at yet, but we haven't really gotten any. I haven't gotten any feedback on this. Next slide, please. Briefly, there are two extensions. There's one accepted media types, which goes into leaf nodes. So those can be in the leaf nodes in your ratchet trees, and so you know what media types are supported by each of the members of a group, and in key packages in the leaf node in the key package, so that you when you're fetching a key package to go and add someone into a group, you know what media types they support then. In the group context, you have a required media types extension, which you can use to say these are required for this particular group. That's optional. You don't need to have a required media types. And of course, you can use media types that are not included in the required media types as long as it's clear what the members who do not support those need to do. And of course, there is the standard MLS mechanism for how you change extensions inside of leaf nodes and how you change extensions inside of group context. Group context, you use a group context extensions proposal, and you use an update or update path for leaf nodes. Next. Okay. Probably the most unique thing about this extension is that it has an application framing mechanism. So if there is a required media types extension in group context, then the application data is assumed to use this application framing mechanism, which is just this struct up here, which you provide the media type, and then you provide the application content with the length, and Bob's your uncle. If the media type is a zero length vector, then you assume that the media type is the first type in the required media types list. Next slide, please. Okay. So if you have not looked at this, and if you feel this is interesting, please have a look. Mimi is basically going to reference this. So I would appreciate some feedback, even if it's, yeah, that looks fine. Okay, group trust anchors. So I wrote a very short, yeah. Oh yeah, Ted. Sorry, the microphone is kind of, I will stand in a slightly different angle so I can see that part of the screen.
Ted Hardy. Thanks. I have looked at this before and I looked at it again. And I think the one thing that's a little bit odd about it and right now is the discussion of multi-part alternative, because it's not clear reading it whether you mean multi-part alternative to be used where each of the various clients is selecting a different alternative out of the multi-part alternative message, or whether the presumption is that any individual client that gets the multi-part alternative will do so. So it's not clear whether what you're sending is a concatenation of all of the types which might be used by the different clients, or some subset that's appropriate to the sender. So I think that language needs to be cleaned up a little bit. And I will tell you, multi-part alternative has had a long history of it doing
Being
surprising
confusing.
things.
Yes.
Not necessarily pleasant surprises either. So you may want to consider carefully whether that's actually a useful long-term path, or whether you want to do something else. I would definitely, in general, look at all of the multi-parts and go, let me think carefully. Multi-part mixed, all of them are a little bit odd, and so
yeah.
That's one where you might want to look at the language and see if you can tighten it on how the different clients are expected to use it, if it's going to all the clients, or how it's being constructed. Thank you.
And the intention was that, for example, if I have 12 members in a group and some of them support Markdown and some of them support HTML, and I wanted to put something more fancy with using HTML, that I would send an alternative that has both. I would send a single encrypted message that has both the Markdown and the HTML, and I would put them in the preferred order, and I would expect each client would look at it and would use the most preferred, the most preferred part.
Yeah,
that
that's
it supported.
Yeah. Okay. So that's the kind of tricky bit, is like how you do this at intersection is never been. It is something that is kind of specific to different usages of it, and so if you're actually expecting that the alternative order is being set by the sender, and that the client picks the first occurring alternative based on its accepting that media type, surprisingly enough, you may need to say that out loud. Because while you might think you'd read the MIME specs and that's what they say, a lot of times that's not what actually happens. So you may want to say it out loud.
Okay, thank you. Okay, trust anchors. So next slide, please. This was a very short internet draft that I sent right before the deadline. So the problem, we are doing federation right now. We're doing federation with MLS. And one of the things that we noticed is that we wanted to start using identity and use certificates for user identities. And we needed a list of trust anchors to do validation of identities. And, you know, if they were all of my I had a bunch of trust anchors in my operating system or in my application. That's great. But I really don't want to trust any of the several dozen trust anchors and any intermediate certificates that may have been rooted in those to make an assertion about every domain that I federate with. I'd like to be able to restrict that and make that more precise. So this is, for example, let's say I have atlanta.at, which is federating with biloxi.be and chicago.ch. So I should be able to say atlanta.at is using the intermediary, ca.atlanta.at, which is rooted in such and such certificate for identities in that domain. So even if intermediary ca.atlanta.at is compromised and atlanta.at, the service tries to send something, it cannot impersonate biloxi.be or chicago.ch if those use different trust roots without being detected by the clients from the other domains. So I see Joelle nodding. This is good. Okay, next slide, please. Okay, so the mechanism I proposed was pretty straightforward. So this is a group context extension with a list of domain, in this case, credential pairs, but inside the credential, if it's X509, it would be a cert chain. And so I could put a root cert, or I could put an intermediary cert and its root cert. So I could validate that this is Biloxi for anything with the domain biloxi.be in this group. This is the cert chain that I want to use for biloxi.be. For atlanta.at, I want to use this cert chain. This is for this to, the way I envisioned this is this would have to be, whatever this is rooted in would have to be already in your OS or application root certificate list. So it's not like we're introducing a new way to create a brand new root cert. Whoops. Richard.
Yeah, so it seems like there's a little bit of a definitional issue here, in that you're trying to define validation rules per domain, but I don't feel like we really have a notion of which clients in an MLS group belongs to which domain. Do you have a theory on how I evaluate which of these valuation rules to apply to which member of the group?
I have my own answer to that, which would be that if I have a URL that has a domain portion in it, however that happens to be constructed, that it would match that domain.
So
now,
it may be
certain hand waving about the actual matching algorithm, but yes.
Yeah, I think we just might need a little bit more definition in terms of how a leaf node gets marked as belonging to one of the domains, whether that's like a certificate profile or an extension to the leaf node, so that claims which domain it's part of or something like that.
Okay.
You done, Richard?
Yeah, go ahead.
So as I understand it, the concept here is that I am Alice at Atlanta, and I'm authenticating with a certificate that has the subject alt name, I suppose, alice@atlanta.com, and
For
that is
example.
signed by some trust anchor.
Yeah.
So I mean, like, I think first of all, like that's like assumes like the existence of some X59 profile for this, which doesn't yet exist. But so so the idea would be that Bob has a list of like CAs that he think is acceptable for Atlanta.com, and he
And provide, I mean, that it would particularly be provided in this group context. So if you're federating with, 3 domains, that there would be.
Yeah. So I mean, like, there's a bunch of prior art here, which did not work out well. Which I mean was better implemented than this, frankly, and did not work out well. So I mean, like, what happens when my cert gets updated is like question one. Like, you're giving your cert chain, and the guy like reissues, and like now like nothing works. So I think like I mean like having a cert chain like this is like going to be disastrous. But like there's like a bunch of art here in web PKI context with HPKP, and like it was completely abandoned because basically it was unmaintainable. And so I'm like very skeptical of this in this case.
So I mean, you mentioned the specific case of a cert chain being updated. We have a way to update group context extensions and leaf nodes.
Yeah, but the use case that people were concerned with HPKP was you create a situation where things were unworkable for a while.
Mhm.
And it was precisely people got concerned about people routinely managed to brick their web servers this way. And so, I mean, yes, in principle, these are all fixable. But my point is, this requires a lot of coordination and cert chains, like real cert chain evaluation often sometimes involves like things like AI chasing. It's just like this is like a very brittle system that you're trying to deconstruct.
A very
brittle system you're attempting to construct.
brittle, yes.
So I think I'm sort of like, like I understand why you might want this, but like I'm just saying like this is like something that the web tried and like abandoned. So I think that like that they give you some real pause about doing this.
Well, I think there may be an interesting difference here from the web in that in the web, certificates kind of just show up, one TLS transaction to another. In MLS, in order for a certificate to come into the group, the leaf node has to do an operation. So in principle, we could augment the validation rules for that operation. So if an operation was going to introduce an invalid certificate that was invalid according to these rules, then it would fail, which would mean you would be forced to update the rules to allow your new certificate before you.
There's already language in the draft actually that says that too. So.
But I guess my point is, who updates the rules? Who's responsible to update the rules?
Which rules are you referring to?
This list of certificates.
If anyone changes the group context, they are required to make sure that it's consistent, which is already in.
So absent any application layer, rules about who can do what, by default, MLS allows anyone to update the group context extensions. And so any member of the group could update these rules.
Right. So, but this just seems like a great opportunity for things to go very, very badly wrong, right? Where you add somebody, you like invite somebody to the group, and like you configure the extensions, and like there's a cert chain change, and then they can't join, and now you're waiting for the person who can modify the group to be online. It just seems like a lot of things can really go wrong here. So like, I guess like it seems like a minimum what you need here is like to go back and like read the literature on HPKP and why it was deprecated, and like explain why this is not going to have all the same kinds of problems.
Okay. Any other comments on this? Okay. Anyway, I did get 2 suggestions about this, one from Marta, which was that it would be nice to be able to use a hash or a reference of some kind to the root cert. And in a trivially fast search, I was not able to find a sort of canonical, this is the best practice reference for referring to. Go ahead.
Sure. Well, what HPKP did was use the SPKI,
Mhm.
which is like strictly like less brittle than this. So like, I think if you're, again, like I would like use SPKI if you're gonna use anything.
So there is an extension called hash of root key.
Mhm.
That was an X509 extension, but it's just a hash of the SPKI. So or just the key, I think actually. But in any event, we can find pointers for that stuff. if we
Yeah.
need it.
Yeah, the hash of the key would not be particularly good for this. So Richard also made some comments about, that this could be used for distribution if there were if there were specific, very clear ways to authorize new keys. I wasn't comfortable with, because I had been thinking about the use cases in a very narrow scope. I was not comfortable with adding any of those, but I'm just adding that here. So, anyway, I encourage, I'll post something regarding the literature that on SPKI and the things that Ecker mentioned. But if anyone is interested in this, please make yourself known. Okay. Next slide, please. How are we doing on time?
You got 14 minutes, and it sounds like the name of an art film.
Okay. So I didn't submit a draft on this. I didn't have time, but this was something that had been bothering me since we got back our comments and discusses from the ADs on the protocol and architecture documents. And so here's a quote. The issue of inability for a client to remove itself from the group by itself seems unsolvable. I would like to see recommendations in the document for clients wishing to exclude themselves in situations when other members for some reason don't cooperate in the process. And I could not agree more. This is a royal pain in my butt. Implementing leaving, it just is really, really uncomfortable. And the reason for that is external commits cause we have specific language in external commits that say that because you can't properly verify pending proposals and probably didn't have a way, any defined way to know about pending proposals, that you ignore pending proposals and they become invalid in the context of the external commit. And then any proposals that had been pending in the previous epoch, once that commit is accepted, the sender of those proposals is expected to magically cause those things to be resent. So effectively what this means is you have someone who tries to leave, they're on a slow device or a slow link, and you have a bunch of people joining and they need to stick around in the group for several epochs waiting until someone finally commits their leave or their remove proposal. That's really ugly. Next slide, please. So one possible way we could solve this is something like a leave proposal, which only would apply, it would be like a remove proposal, but it would only apply to the member sending it themselves, who would sign it in a way that can be verified by an external joiner. In other words, you don't need to use material from inside the group in order to be able to verify the leave proposal as you do with a remove proposal. And the semantics here, there's a field when you define a new proposal type, whether it is allowed in external commits. Currently, external commits say that you can have a remove proposal, but you can only remove a previous version of yourself. And that's not what we want to do, because the committer is not the person who wants to leave. It's a person who actually wants to leave. So the leave proposal would have different semantics. And the change that we would need here is that it would be expected the leave proposal would be included in external commits, and the external committer would be able to verify the signature, and presumably when they get the group info that they need to do the external commit, that they would also get the leave proposal or proposals that were pending for the group at the same time. So I find this problem to be really annoying, and I would like to have a solution for it, regardless of whether it resembles this this particular proposal in any way. What do you all think? Raphael?
Yeah, Raphael Roberts speaking. So first of all, I agree with you. This is generally not really compatible with external commits. I realized that myself not so long ago. And probably something we should have addressed earlier. And also, what I actually wanted to speak to is to the third proposal you're making here, which you didn't really explain.
Yeah.
Because I think that is already the case. So if there are pending commits, you cannot send application messages. You have to commit to them. And so what I'm wondering in general is if, you know, in real life, whether that is really going to manifest or not. Because assuming that there are some clients that come online at some point, and well, they're programmed in a way that as soon as they see a leave proposal, then they issue a commit. So statistically, this is much more likely to happen quickly than someone joining with an external commit. Not always, it's not guaranteed, obviously, but there might be a very good chance that you rarely run into the problem that you stick around longer than you want to in a group. So with, I mean, more guidance for implementers, this could alleviate most of the problem.
So the case where we saw this was when implementing conferencing using MLS, where you have a bunch of people leaving and a bunch of people joining basically on the hour or on the half hour. And so as a bunch of people are trying to, like basically a bunch of people say, I want to leave, and they can't commit the pending proposals. And the people who are joining can't commit the proposals either. And you might end up with, you know, in some of our cases, you might end up with 15 commits that go by, and that, you know, there's a commit. Oh, I need to resend my remove. Oh, no, there's a new commit. No, I can't do it again. And so particularly we also have cases where, you know, somebody wanted to leave and then they crash, you know, and then they end up coming back, you know, a few hours later, and they're it just is, it's a very unappealing situation. And I agree that it's not that in many of the sort of most normal situations that don't involve, for example, conferencing, that there are a lot of things you can do that cause this problem to not happen. But in this particular use case, it gets really ugly.
Yeah, that's a good point. But just to put that more in context, as you already started doing, so MLS was initially developed for asynchronous messaging. We wanted to work for real-time communication as well, but there's a bunch of things that are more challenging when using MLS for real-time communication, and this is certainly one of them. But yeah, I understand that in the particular scenario you're describing, that might be a problem, and you would have to come up with an entirely different solution to address that. Yeah. So, and maybe just to conclude, so what you're proposing to include the leave proposal in the external commit, it slightly changes the logic and the security we have around that, because for now you needed to have proof that you are part of the group, and not only proof that you own the private signature key to the public key you have. So it's strictly less in terms of security, and closer to external proposals in that sense. That doesn't mean that it's a huge problem. I just want to point out it's different and probably needs some more consideration.
So I'm curious in general if folks think that this is worth writing up an internet draft, concrete proposal, doing a security evaluation for. We would implement it if it existed.
I think a draft is needed to solve the problem, but maybe we can iterate a bit on that design in particular. I have some ideas I want to share with you too.
Okay, but the only question that I want to ask right now really is, is there interest and energy in solving the problem? Okay, any other thumbs up other than Joel? Okay, I'll take what I can get. Okay, next slide, please.
All right. Yeah.
Okay.
Time check. We got like 5 minutes.
Yeah,
All right.
I will be 1 minute
Policy
longer.
knobs.
Okay, next slide, please. So the architecture document has a list of operational requirements. There they are. You can imagine that being able to use the agreement of an MLS group to make sure that everybody, particularly in a federated environment or an interoperable environment, was operating off the same set of policy knobs might be kind of useful. So I just wanted to flag this as a, this might be an interesting opportunity for an extension. Next slide. And so it might be interesting to have a machine readable way of communicating some of these policies, whether or not it is, even if it's like an out of band, something that's used out of band. And then it may be interesting for the same or different subset of those policy knobs to be able to provably agree within an MLS group that those parameters are the same. That was all.
Oh, okay, great.
Next slide. Thank you.
All right, great. Okay, well, thanks. Remember, before you leave, if you came in late, scan the QR code so we get an appropriately sized room. Thank you for all your work, effort. Anything else, Paul? We're good? Awesome. Thank you very much. Oh yeah. If you want stickers, I got stickers.
How do I get a t-shirt? How do you do a t-shirt? Like, is it sold somewhere?
Remove proposal?
Once it's decentralization, give them the and you have a person in the mini session who is and I just be decentralized.
I don't know.